Hello everybody. Today's chapter will be chapter number 10, that is circles. In this chapter we will talk about circles and some terms related to it. First of all, this is the shape of circle. Everybody has seen these type of bangles. This is the shape of circle because circle is a collection of all the points. Fine. Let us draw this circle here. It's a collection of all the points whose distance from a fixed point is fixed. Means every point, because infinite points are there on the circle, their distance from this fixed point, which is called as center, is fixed. And all these fixed distances are called as radius. Now, before starting this chapter, we must know about certain terms which are very important. First is tangent and second is secant. For this, I am taking three circles, 1, 2 and 3. This line is drawn. This line is drawn. Now one more line is drawn. In figure number A, we have no common point. In figure number B, we have two common points, P and Q. In figure number C, we have one common point, that is R. If only one common point is there with circle and this line is said to be tangent. So what is tangent? Any line just intersecting the circle at one point means they have only one common point is known as tangent. Now second figure, figure number B. We have two common points means this line is intersecting circle at 2 points. This line is called as secant. Now third one, that is figure number A, has no common points, so there is no special name for it. Fine. After knowing tangent and secant, we will solve or we will prove two theorems which are very important for this chapter. First is, again I am taking one circle, one tangent is drawn, and on this tangent, this is the point of contact. If O is the center of the circle, we have to prove, this is theorem number 10.1, we have to prove the line segment joining center to this point of contact is always perpendicular to the tangent. Let us take tangent as x, y. So we have to prove OA is perpendicular on x, y. What is given to us? Given one circle whose center is O and radius is R. And xy is tangent. For this I am doing just one construction. You already know beta that from one point many rather infinite lines can be drawn on this given line. But the line which is shortest is always perpendicular. So this also we will take help of this concept. I am drawing one more line. that is OP. OP is drawn on XY. Proof. As you know, OP is equal to OQ and PQ. And OQ is the radius also. So OA is equal to OQ. Both are radii. So they are equal. We have to prove OA is shorter than OP. Or we can write here OQ is shorter than OP, because OQ is a part of OP. But OQ is actually equal to OA. So in place of OQ, I will write OA, which is less than OP. As we know, the line drawn from any point to the given line, if it is shorter, it will be perpendicular as compared to the other lines. Okay, so we will conclude that OA is perpendicular to XY. This is the proof of theorem number 10.1. Now after this, I will take theorem number 10.2. For theorem number 10.2, now theorem number 10.2, I will draw one circle again. So what is there in this theorem? First of all, statement. What is the statement of this theorem? This is external point. This is circle. From external point, two tangents can be drawn on the circle. We have to prove that tangents drawn from an external point to the circle are always equal. So statement is tangents drawn from an external point to the circle are always equal. Once again, what is given to us? Given is one circle whose center is O and radius is R. AB and AC are two tangents. To prove AB is equal to AC. For this I am doing construction. What is the construction? Just join OB, OC and OA. Join OB, OC and OA. As we know, these angles are of 90 degree. Why? The line segment joining center to the point of contact is always perpendicular on the tangent. Proof. To prove that they are equal, I will take concept of congruency. So first of all, I am taking two triangles, that is triangle AOB and triangle AOC. I will make them congruent. First of all, angle 1 and angle 2, both are 90 degree each. Second, side opposite to the right angle is actually hypotenuse, and now which is common in both the triangles. So OA is equal to OA, you will write common. Third thing, the radius are equal. So OB is equal to OC, both are radii. Fine. Now what is the concept of congruency? We have to write the criteria also. Right angle are opposite side hypotenuse, that is H, and one side is taken, that is radius, so that is S. By using RHS rule, triangle AOB is congruent to triangle AOC. If both the triangles are congruent, their corresponding parts are equal. So AB is equal to AC by CPCT. CPCT stand for corresponding parts of congruent triangle. So this was all about for the theorem number 10.2.